Welcome everyone. My name is Arthur Benjamin and I am a mathemagician. What that means is I combine my loves of math and magic to do something I call mathemagics. Now I'm going to do some mental math problems for you. We'll start off with some small problems and we'll work our way up to some big problems. I'll start by multiplying numbers by 11. Would you give us a two-digit number to multiply by 11? I have here someone with a giant calculator. He's my press the digitator and he's going to verify most of the answers. Okay, a two-digit number 36 times 11 is 396. How about another two-digit number? 73 times 11 is 803. How about a three-digit number this time?
489.
489, that's 5,379. Great. The other thing I love doing is squaring numbers, multiplying numbers by themselves. Well, we'll start off easy with numbers that end in 5. Give us a two-digit number that ends in 5.
65.
Times 65 is 4,225. How about another two-digit number? 35 times itself is 1,225. How about a three-digit number that ends in 5?
385.
385 is 148,225. Hi. My name is Arthur Benjamin. I'm a professor of mathematics at Harvey Mudd College, and ever since I was a child, I've had a passion for playing with numbers. I would take a math problem, try to solve it several different ways in my head, and if I was careful, would always get the same answer. I found that consistency of mathematics to be absolutely beautiful, and I still do today. In fact, I'm sure that it was this early exposure to the joys of mental arithmetic that led to my becoming a professional mathematician and mathemagician. I've written books and have given thousands of talks to audiences around the world on how to do math in your head with confidence, accuracy, and speed, sometimes faster than a calculator. In this course, I will share all of my calculating techniques with you. In school, most of the math that we learn is done with pencil and paper, and yet I would say that it's far more important to be able to do the math in your head without pencil, paper, or calculator. There are many situations when it makes more sense to do problems in your head, like when buying groceries, or reading the newspaper, or playing a game of Scrabble, or listening to sales figures at a meeting. The ability to do rapid mental calculation offers lifelong advantages. Students who master mental math have a competitive advantage in the classroom. Not only are these skills empowering and a big boost to confidence, but they can actually be a lot of fun. Over the years, I've received feedback from many parents who said that their son or daughter was bored in their math classes, either because it was too fast or too slow. But after learning my techniques, their attitude and performance improved dramatically. And anyone who learns to think about numbers, as we do in this course, will approach more advanced math with better number sense and with more confidence and enthusiasm. It can also lead to higher standardized test scores on the SAT, ACT, and grad school exams. Some of these exams do not allow calculators, and even if they do, an improved sense of numbers will reduce the chance that you make a calculation error and makes it easier to check an answer. These are useful skills, not only in school, but throughout life, whether you're using them at the ATM machine, computing the tip at a restaurant, or shopping for a mortgage or car loan. And as we get older, research has shown that it's more important to find activities that keep your mind active and sharp. Not only does mental math sharpen the mind, I think it makes you a better problem solver overall. Our first 6 lectures will focus on the fundamentals: mental addition, mental subtraction, mental multiplication, and mental division. We'll also explore real-world applications of these techniques, as well as the art of guesstimation for problems that do not require an exact answer. Once we have mastery of the basics, we'll branch out in interesting directions. We devote one lecture to pencil and paper mathematics, but done in ways that are seldom taught in school that look absolutely magical. I'll show you a fun way to improve your memory for numbers, which will allow us to perform even larger mental calculations, but it can also be used for memorizing phone numbers, credit cards, and dates. And speaking of dates, I'll teach you my method for determining the day of the week of any date in history or future. In our final lectures, I'll demonstrate and explain how to do enormous calculations, like the squaring of 5-digit numbers or the cube root of 6-digit numbers, and discuss techniques used by world record lightning calculators. Even if you do not aspire to be a grandmaster mathemagician, you'll still benefit tremendously by acquiring the skills taught in this course. Remember, the point is not to see how smart I am, but how smart you can be. So let's get started. Now, all I'm assuming is that you can do the simplest of addition and multiplication problems. For addition, you just need to be able to add a 1-digit number, perhaps followed by some zeros, to anything. And by a 1-digit number, I mean any number from 1 to 9. So you should be able to easily add numbers like 3, or 30, or 300, or 3,000 to any number. For example, let's take the number 42. 42 plus 3 is 45. 42 plus 30 is, you should be able to get 72. 300 plus 42, that's easier, is 342. Or 3,000 plus 42 is 3,042. Couldn't you just hear the answer, especially for the last couple problems? I want you to get into the habit of hearing the problems, and most of all, thinking from left to right. Okay, for example, tell me what is 2 billion plus 2 billion? The answer is, say it, 4 billion. Right? Now, when you did that problem, I don't think you saw 2 followed by 9 zeros plus 2 followed by 9 zeros. You didn't really see the problem. I think you heard the problem. You know that 2 plus 2 is 4, and so 2 billion plus 2 billion is 4 billion. The word billion lines things up in your ear, not your eye. Here, let's do a couple more problems. Try the problem 800 plus 400. 8 plus 4 is 12, so the answer is 1200. How about 70 plus 60? 7 plus 6 is 13, so you want to say 13t, but of course the answer is 130. It's also easy to add numbers when there's no overlap. For instance, if I say 70 plus 2, you get 72. Or 400 plus 25, you get 425. 360 plus 9, just say it, is 369. Or 2300 plus 45 is 2345. Now admit it, you did these problems from left to right, right? And yet, if you saw those problems on paper, you might have been tempted to add them from right to left. See, as you're looking at these problems, isn't there that temptation to do 0 plus 2 or 0 plus 5? In your head, I claim it is much more natural and ultimately much faster to calculate from left to right. For most of the problems that I'll give you, I will let you see the problem, but I really want you to try to solve these problems as if you're only hearing them. This will enable you to develop your left to right habits and stronger mental math skills. As for the simple multiplication, I'm assuming that you should be able to multiply any number by 10, 100, or 1,000 by attaching the appropriate number of zeros. For example, 42 times 10, we attach 1 zero to get 420. For 42 times 100, we attach 2 zeros to get 4,200, or 4,200. For 42 times 1,000, you'd get 42,000 by attaching 3 zeros, or simply by attaching the word thousand. And last but not least, you need to know your multiplication table up through 10. There are actually some tricks to memorizing the multiplication table which might be of interest to students, parents, and teachers, so let me say a few words about that now. At first glance, the multiplication table seems to be quite imposing. After all, it contains 100 facts. Look at it. How could any child be expected to memorize that? And yet, I claim that more than half the table takes no time to learn. It's obvious how to multiply numbers by 1 and multiply numbers by 10. And multiplying by 2 is just an easy addition problem, right? 6 times 2 is just like 6 plus 6, 12. So if you eliminate 1, 2, and 10, we've reduced the problem to memorizing a 7 by 7 table, which has only 49 entries. In my experience, the stumbling block for students memorizing the multiplication table is learning their multiples of 3 and 4. Once you know that, there's really not that much more to learn. I teach students their multiples of 3 by first counting by threes, 3, 6, 9, 12, and so on. And then we do it faster, and then we do it faster, and eventually it's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Then I'll ask them 3 times 1 is, 3 times 2 is, 3 times 3 is, in order, so they associate the multiplication problem with the sequence they've just learned. And then we do it in mixed up order until eventually they know their threes table. I teach the multiples of 4 in the same way. We learn to count by 4s and eventually do it very quickly. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And that leads to learning 4 times 1, 4 times 2, 4 times 3 in order, then eventually out of order. And learning the multiples of 5 is even easier since every multiple of 5 ends in 5 or 0. There's also a simple trick to multiplying by 9s. You'll notice that the multiples of 9 have the property that their digits add up to the number 9, right? Like 9 times 2 is 18, and 1 plus 8 is 9. 9 times 3 is 27. 2 plus 7 is 9. The digits of 36, 3 plus 6, add up to 9, and so on. Also, the first digit is 1 less than the multiplier. So 9 times 2 begins with 1. And 9 times 3, 27, begins with 2. 9 times 4, 36, begins with 3, and so on. So a problem like 9 times 4, since it will begin with 3, and it will end so the digits add up to 9, we can figure out the second digit, which is 6. So 9 times 4 is 36. Once we know the multiples of 1, 2, 3, 4, 5, 9, and 10, this reduces the multiplication table to a tiny 3 by 3 square. And people find it easy to learn the one-digit squaring problems. 6 times 6 is 36, 7 times 7 is 49, and 8 times 8 is 64. So it just comes down to learning 3 hard facts. 6 times 7, or 7 times 6, is 42. 6 times 8 is 48, and 7 times 8 is 56. By the way, I've encountered schools that now ask their students to memorize their multiplication tables up to 20. By the end of this lecture, I'll show you a fast and easy way to multiply any two numbers between 10 and 20. In this course, you'll find that most of the methods have a lot in common. I view mental calculation as a process of simplification, constantly making the problem easier. You start with a hard-sounding problem, then you break it into simpler and simpler pieces, making the problem easier and easier until eventually you are simply left with an answer. It's like the writer Henry David Thoreau said, simplify, simplify, simplify. Except I'm not sure why he had to say it 3 times. Okay, so let's simplify. Consider the multiplication problem 432 times 3. Now that sounds hard, but it's just the sum of 3 easy problems. 3 times 400 is 1200. 3 times 30 is 90. And 3 times 2 is 6. 1200 plus 90 plus 6 is 1296. I want you to notice a few things about our solution. When adding the numbers, it's easier to add from largest to smallest instead of smallest to largest. The sum 1200 plus 90 plus 6 is easier than 6 plus 90 plus 1200. The first way is easier because the number 1296 is read and pronounced 1296. It's not pronounced 6 and 90 and 1200. Let me say a few more words about doing mental math from left to right. On paper, we usually go from right to left, and that's fine for doing the math on paper. But if you want to do the math in your head, then I say you should do it from left to right. After all, we read numbers from left to right, we pronounce numbers from left to right, and with just a little practice, you can calculate from left to right much faster. For example, consider the multiplication problem 54 times 7. Now on paper, you might start this by doing 7 times 4 to get 28. But when doing the problem mentally, it's better to start the problem with 7 times 50, which is 350. It's better because this gives you a good estimate of your answer. Whereas if you do the problem from right to left, all that you know is that your answer ends in 8. And however, you might say that it's innately more important to know that the answer is a little bit bigger than 350 than to know that it ends in 8. So by going from left to right, you immediately have a sense of the size of your answer. Now, to get the exact answer, we start with 7 times 50 to get 350. Then we do 7 times 4, which is 28. 350 plus 28. Now we're going to add those together from left to right, and you get, let's see, 350 plus 28. That's 300 and what? 50 plus 28 is 78. And there's your answer, 378. By the way, in this course, I'll be asking you a lot of questions. When I do that, you might see something on your screen like this. I may only pause for a beat before giving the answer, so feel free to use your remote control and pause me so you can think of the answer yourself. You'll get much more out of the course if you're an active participant. If sometimes I go too fast, that's because there's just so much in this course I want to show you. And I know you have the ability to rewind me as needed. Let me say a few words about practice. Just by watching this course, you will learn all the techniques that are required to become a fast mental calculator. But if you want to actually improve your calculating abilities, then just like with any skill, you need to practice. And the more you practice, the faster you'll become. And once you get proficient, it's very easy to maintain, like riding a bicycle. In this course, as we learn new skills, I'll show you some of the techniques that I use for practicing. But now, I want to show you some skills right here, right now, that you'll be able to do with almost no practicing at all. Let's start with a simple bit of mental math, how to multiply the number 11 by any two-digit number. All right, it's very easy once you know the secret. Let's start with 23 times 11. Okay, now it's as easy to do as 2 plus 3. 2 plus 3 is 5, and that's the answer, 253. Here, let's do another one. Let's try 53 times 11. 5 plus 3 is 8, and that's the answer, 583. Here, you try 81 times 11. Don't just say the middle number, say the entire answer. What do you get? 891. Now, before you get too excited, I've only shown you half of what you need to know. Because what if the number adds up to something bigger than 9? Suppose I had a problem like 85 times 11. Now 8 plus 5 is 13, but the answer is not 8, 13, 5. There's only room for the 3. But the 1 makes the 8 carry, and the answer is 935. Good. Here, let's try 77 times 11. Okay, so what do? 7 plus 7 is 14, so what's the answer? 847. Last one, we'll do the largest two-digit number possible. Let's do 99 times 11. 9 plus 9 is 18, so what do you think the answer is? 1089, 1089. How about three-digit numbers? Let's take the first 3 digits of pi, 314 times 11. Now, the answer still begins with a 3, and it ends with a 4, and here's how to figure out what we have in the middle. 3 plus 1 is 4, 1 plus 4 is 5, and that's the answer, 3454. In fact, we can multiply that number by 11. It still begins with a 3. It still ends with a 4. 3 plus 4 is 7. 4 plus 5 is 9. And 5 plus 4 is 9. Congratulations. You've just multiplied 3454 times 11 to get 37,994. One of my favorite feats of mental math is squaring numbers, that is, multiplying numbers by themselves. For example, 5 squared would be 25. Now in this course, you will learn how to square 2-digit, 3-digit, even as high as 5-digit numbers in your head. Now, it's especially easy to square numbers that end in 5. Here are all the 2-digit numbers that end in 5. There are just 9 of them. And here are their squares. Now, notice that all of the squares end in the number 25. Now let's look at the square of 35. We know that it ends in 25. How does it begin? To figure out how it begins, we take the first digit of the number, that's 3, multiply it by the next higher digit, which is 4. 3 times 4 is 12, and that's the answer, 1225. Here, you try 65 squared, 65 times itself. Now, how does it begin? It begins by taking 6 times the next higher number, 7. 6 times 7 is 42. And how does it end? It always ends in 25. So there's your answer, 4225. Okay, last one. Try 95 squared. All right, what's the answer? You tell me. I'll wait. 9025. 9 times 10 is 90. Attach the 25, and you have 9,025. Incidentally, this method can also be applied to 3-digit numbers. For example, to square the number 305. If you knew that 30 times 31, or you could calculate 30 times 31 to get 930, then 305 squared would be 930 with a 25 attached, 93,025. Okay, now let's extend the pattern. We know that 85 times 85 is 7225, but notice this. 84 times 86 is 7224. And 83 times 87 is 7221. 82 times 88 is 7216. And 81 times 89 is 7209. Do you see the pattern? The answers all begin with 8 times 9. They all begin with 72. And they end with the product of the last digits. So 84 times 86 ends with 24, which is 4 times 6. 7221 ends in 21, which is 3 times 7. 7216 ends in 2 times 8. And 7209 ends in 1 times 9. This method works whenever the numbers being multiplied have the same first digit and the last digits add up to 10. So, for example, let's do the problem 53 times 57. They have the same first digit, 5, and their last digits are 3 and 7, which add up to 10. So we can use the latest pattern. How does the answer begin? It begins by taking the first digit, 5, times the next higher digit, 6. 5 times 6 is 30. And what do we attach? Simply the product of the last digits. 3 times 7 is 21, and there's your answer, 3021, 3021. We'll do more problems like this, and I'll show you why it works later in the course. But for now, I want to teach you some other skills that you can start using immediately. Earlier, I mentioned that some schools now require students to learn their multiplication tables up through 20. But I claim that once you know your tables through 10, the tables through 20 are actually quite easy to learn. Let's first look at what happens when we multiply a number between 10 and 20 by a one-digit number. Here's a table with the numbers 11 through 19 multiplied by the one-digit numbers. I don't recommend memorizing this table since the answers can be calculated without too much trouble. You simply multiply the one-digit number by 10 and by another one-digit number, then add the results. Let me show you what I mean. To do 13 times 6, we do 6 times 10, and we'll add 6 times 3. 6 times 10 is, say it, 60. 6 times 3 is 18. Add 60 plus 18, please do it from left to right, and you get 78. So 13 times 6 is 78. Here's one more. Let's do 18 times 8. All right, we do 8 times 10, which is 80. 8 times 8 is 64. Add them together. 80 plus 64. Now 8 plus 6 is 14. So 80 plus 60 is 140. With the 4 we have 144. And that's about as hard as they get. Here, let's just do one more for practice. Let's do 19 times 7. 7 times 10 is 70. 7 times 9 is 63. 70 plus 63 from left to right is 133. By the way, another way to do this same problem is to treat 19 as 20 minus 1. So if you want, you could do 7 times 20 and then subtract 7 times 1. Let's see, 7 times 20 is 140, and we subtract 7, we get 133. We get the same answer. Okay, now let me show you a mental multiplication shortcut when both numbers are between 10 and 20. We'll start with the problem 13 times 14. You might first want to pause and try to do this problem in your head right now and see how long it takes you. But I'll bet my method is going to be a little faster. Okay, to do 13 times 14, here's what you do. We take 13, the first number, and we add 4. 4 was the last digit of the second number. Okay, so 13 plus 4 is 17. Take that 17 and multiply it by 10. We always multiply it by 10 to get 170. Almost done. All you have to do is multiply the last digits together of the original problem. 3 times 4 is 12. 170 plus 12, that's a pretty easy addition problem from left to right, is 182. And that's the answer. Here, let's try 17 times 15. How do we start? We take 17 plus 5, which is 22. Take that 22 and multiply it by 10. 22 times 10 is 220. And all we add to that is 7 times 5, 35. You tell me 220 plus 35 is 200 and what? 20 plus 35 is 55. That's the answer, 255. Again, this method will work for multiplying any two numbers between 10 and 20. In a moment, I'll show you the entire multiplication table of numbers between 10 and 20. When I do that, I want you to pause this DVD for just 2 minutes. Then I want you to try to do 1 or 2 problems like 12 times 18 or 14 times 19. Then look back at the table to see if your answer was right. Okay? Pause. All right, have you tried it? If you haven't, please try it now. Okay? So without looking at the screen, I'll give you one more problem to do. Are you ready? Try the problem 18 times 17. You may want to pause to try it by yourself first, because I'm going to say the answer in a couple seconds. All right, what do? We do 18 plus 7, which is 25. Multiply that by 10 to get 250. What do we add to that? 8 times 7, which we know is 56. 250 plus 56 is 306. And that's the answer. Did you get it? Can you imagine trying to do that problem in your head, 18 times 17, the way you used to do it? Not bad for just a few minutes of work. Now, go and practice the skills you just learned, show them off to your friends and family, and enjoy their reaction. In this lecture, we've learned some of the fundamental strategies for doing mental arithmetic. We do all of our calculations from left to right, starting with the largest numbers and working down to the smallest. Some of the skills we learned you can do almost instantly, whereas other skills will take a little bit of time and practice to master. Mental math is great exercise for your mind, and your mathematical and logical skills will improve dramatically. Well, what are you waiting for? Let's get ready to have fun with numbers like you've never seen before as we explore the secrets of mental math together.